requirements analysis. So the size you get out of this, you have the total size which you'll use to the schedule and cost estimates of the projects. You have the detailed function point analysis, part of the requirement analysis, that will use actually going directly into activities. When you're looking at functional point, you're looking at base functional classes. Each of these relates pretty nicely to some functional tests, because for each class there will be some functional test that you have to perform, or at least consider. You will also find during this some borderline requirements which you can use for your change management. Is this inside versus outside, and how much is it? The whole classical discussion that you will get more information about that. You get productivity figures based on the on how much function point are you actually delivering each month, each sprint, each whatever you are doing this one. And those productivity figures you can use also for setting up improvement targets for the projects. So when you're running a project, you can give them not only the target of delivering a product, but also to improve some of their processes along the way. When we are entering this, we are doing two kind of, just to classify them, two kind of development. There are legacy replacement or enhancement projects. That's approximately half of all the time you spend in software development and IT. And it includes some base of legacy code of which we rarely have a very valid requirement specification. But however, it is subject to data mining. You can look at the existing code and you can do some data mining and you can actually find out what the size is of what we already have. Pretty correctly. And that will then give us a good baseline for discussing how much enhancement are we going to do. I guess many of you have seen a project that initially started out to be a one-to-one replacement of an obsolete system. But along the way, it was not a one-to-one. Some sneaking requirements just came in, and well, now we have the technology, could we get, and by the way, we have changed the processes over here, and now we don't have to do it. And then suddenly we have quite a new system, which is very nice, because then if we have the sizing of the old system, if something goes out, well, you just take the size of that is out. Something new comes in, well, that's free. If it's kind of balancing, you have the fact-based, the size-based discussion with the project team users. What is in and what is out. For new applications, it's a different matter. You are looking at something that's not there yet, but there are requirements, and that's where the function points analysis comes into the natural part of the requirement analysis. So whenever you're discussing setting up what is this requirement, you also do the measuring of the size as well. And this analysis method kind of differs with the size of the software. So if you have a very small project, like typically one-man project, a little app or something like that, which is with a size of less than 100 function points. Often it is a one-man show. And let's face it, it's intuitively managed. And it works, because one man can have a lot of complexity inside his head. And as long as he can actually oversee everything, it in the whole development turns out to be a pretty good productivity. So no big deal there, but it doesn't scale at all. And we see that when we move up a little bit of the scale, say a small project less than 1,000 function points. That's where the agile methodologies are really cool. Do prototypes, do requirement analysis tools, starting to do those. And so that's kind of a different method you are applying in your requirement analysis. Still, what you do as part of the requirement analysis is you measure the size. Large projects, say 10,000 function points. Now we're talking a big administrative public systems or something like that. That's where the joint application design techniques and quality function deployments turns out to be very useful to get control of this. Still, there are many other techniques than these. these are the techniques that have been reported into databases, and we know that they are actually supporting these sizes of projects. And for very large projects, say the size of 100,000 function points, there's only one thing to say: don't do them. They are really the sum of all risks, and everything falls together there, and you can easily see requirement creeps of 50% in those huge systems, because the complexity has a tendency to spread around, and it actually makes the whole size of the system, the complexity of the system, to grow exponentially. So that very large system is just pretty bad idea. They perform very bad, and well, altogether, I think very bad. So, for an accounting example, let's look at FISMA now. I just mentioned it just before. Basically, what you're looking at is 7 base functional classes, and they follow the classical 3-layer architecture. You have the UI, including the navigation and the query. You have the input layer. Then on the business layer, you have the output of it, the algorithm and manipulations, the interfaces from other systems and interfaces to other systems. And then we have the data layer, the data storage. These are the 7 classes that we're looking at. Each class, you are looking at the reads and writes and data elements and operations. And it's a simple formula that then adds them all up together in the accounting process. Just took a picture of a poster this size that just describes how you do it, and there are examples on it, and it's really, when you have this in front of you, you're pretty much there. You still need some explanation about what it is, but it is as simple as it can all actually be on this poster here. And you count each one of those classes, and you add them up together, and you have the size of the software. Just for a very simple one here. And inquiry screen, we're looking for a number of data elements and number of reads required. So there's a formula down here saying that the inquiry screen is 0.2 plus the number of data elements divided by 7 plus the number of reads required divided by 2. We count the number of data elements on the screen, it makes 10, and we have the number of reads which goes from the screen, and the search by itself is 2, and we have 2.6 formula. That's it. So it must be as simple as this. So we can just, so whenever a user comes in and say we want an extra inquiry screen, okay, 2.6 function point, that is equals to say 2,600 euros or something like that. And that's the kind of discussion that we should get to, because that's where it gets like in every other industry. So who is doing this counting? Well, all. But of course, in the beginning, it will be the project managers who are very curious about the size of this assignment, and the customer who are very curious about what you should pay for. So when I'm doing this, every time you make a change, every time you are actually discussing these issues, put a size on it, you just put the facts and makes you comfortable with whatever you are actually doing. What is it? Project software, it's the functionality, it's nothing else. So of course, still, it's not the complete price, it also includes the price of the hardware and whatever goes around it, just the functionality. And why? Well, to use it for estimates of costs, schedules, and everything. So, cool. Now for the long list of benefit slides here. And still someone, please wake me up at 1:45. One thing that was very curious to me when I actually was going to this conference, you're sitting here, a lot of testers who will know a lot more about testing than I do. This is something that if you have a base functional class, like, for example, in inquiry, that to this there will always be some standard functional tests that you should actually do in this class. So if you have, during your requirement analysis, found out which classes are there and the size of all of those, you actually have the first input to the estimate on your functional test. Of course, you will have a list of all of them. Then you can prioritize and take those out that you don't feel is representing the risk to the project, if you need to. But I have this feeling, and I'm not sure, and I'm not an expert in this, and if any of you grab this idea and either find that it's nonsense or actually a good idea, please give me a note. But it just feels like when you have done your analysis and have those base functional classes, you have a good list of your functional testing on the software. I guess that could be pretty cool. Other than that, you of course need the size to estimate cost, schedule, based on the size. Have it ever occurred to you to be slightly hard? What we are doing when we are estimating our work is that we put up a measure in time. So how long time are you going to spend on this activity? Not the size, but the time. And when we are measuring the progress, we are kind of measuring the time that has gone, since the last time it's not the stopwatch. And then we are measuring that against the time we originally thought it would be. And then we add something about how much time we do. And it really gives us a very, very bad picture of the true progress of the project, which is kind of the main reasons for projects always being 8% done 80% of the time, as we have probably all seen this. If we go with function points and make the progress monitoring and control based on the real progress, saying now we have delivered 25 out of 115 function points, we kind of know this is the real progress. And now earned value analysis starts to make sense, which it really doesn't if you're only using activity size measures in time. Use it for cost evaluation. Is it the right price that a company is paying for software? Just because it looks similar to the price that they paid last time? Not necessarily. When you dig into these figures, there's a huge variety of what companies are actually paying for the same size of software. There's some measures for a guy in Spain who did a survey on 300 projects. And those who did not use function points, the variation was very, very big. And by the way, the only thing you had left was kind of the hourly rate for the software developer, or the price based on this hourly rate. And it turned out that the more you put pressure on the vendor to lower the hourly rate, the higher the total cost of the software became. There are now statistics that actually prove that, which I find very interesting. Productivity. All teams are different in productivity. When you have the size measures and function point included, you can actually measure and compare those teams in their productivity. And those over there were very good, and those over there were not so good. They can learn from these. And then you start to have a discussion, what are they better? And then they learn. And then you start to learn from each other inside the organization. But only because now you know that there is a performance difference. Use it for planning, obviously, for all the estimates, and for quality control. So whenever we have a kind of a measure saying that this is the amount of defects we found per function point, we can add up, since we know the total size in function point, and found out how much defects we actually have in the code, and we need to find and deal with altogether. Size and requirements completeness. Well, for each of these functional classes, there are a set. This is a template. You can also find it on the web. There is a link here. It actually gives you, when you're a checklist for your review, for your inspection of the requirements. That is based on the functional classes. Each functional classes then needs certain types of inputs and outputs and stuff like that. So we have some completeness criteria that we can use, and a template to use for this criteria. Early sizing techniques, kind of covered that just before, what you can actually see. But there are, in all these methodologies, they have some statistics of how good you can actually measure the data method. For example, the first thing that becomes very stable in the system is the database. The logical layout of the database, the logical data model doesn't change much. You can actually establish that pretty fast. If you, in your system domain, know that in the matter of size, the database, the data layer, the base functional class for data, is between 10 and 15% of the total size, and you are able to measure the functional size of the data layer very, very early. You have a pretty good, just out of the database, just out of the logical data model, you can tell the size of the whole systems if you have some, just a little bit backup data from the system domain. Size and changes, did I cover that? Every time you make changes to this, put a size on it, and that is what we're actually talking about in the situation we're in. Size and estimation. Old historic facts. Nothing beats your own data in your own company. Of course, you have to start somewhere, and that's where you can enjoy the databases that is available out there from ISPSG or from Jones, from Finland, many places. So there is some interesting data you can compare your performance, your cost, your whatever with, but nothing beats your own experience. So if you take the time in your organization to pick out a few exemplary projects, count the size of those, and you have the financial figures of how much time it costs to develop those, then you have to start for your own historical database inside your organization. That will be immensely powerful when you are estimating forward. Because you know the principle of the yesterday's weather. When you're estimating, with all the best computers in the world, you can make models of the weather forecast, and you can hit with, what is it, 72% correctness with the weather for tomorrow. You can hit it with 80% preciseness just by saying it will be just like this. Of course, there will be something that will come wrong in both cases, but apply the same principle to estimations and software, meaning that